Eighth graders, this is going to be a new lesson for algebra. So far we've done a lot of review, but this is going to pick up with what we know about graphing linear equations, and we're going to graph linear inequalities, right? So we spent some time graphing just regular inequalities on one, x coordinate, or I'm sorry, x axis, so to speak, or a number line. Now we're going to talk about the x and the y together. So if we could make sure you have your notes, maybe pencil, maybe 2 different colored pens or pencils might be helpful, ruler. So if you need to get those things, maybe pause and then come on back. Let's just start with a definition here of what it is. A linear inequality, really just, I'll say, what is it? It describes a region of the coordinate plane, and plane, that flat surface, right? Coordinate plane that has a boundary line. Okay. All right, so we draw this boundary line, which is actually the equation or inequality, and this region is what we're describing. Well, what is the solution to this linear inequality? Well, it's the region. So the solution is every point in the region okay. So there's multiple solutions, just like when we had multiple solutions when it was a, on our number line, we would say greater than, and we would shade to the right. Where it would get larger, we would say less than, we would shade to the left, right? And then if it was an equal to part, we would do a solid circle. And if it was not equal to, we would do an open circle, okay? So we're going to use that background knowledge to apply to this right now. But first, let's just say, well, how do we know if a number or coordinate pair rather is a solution? Well, if we use this inequality, 2x minus 3y is less than 15, how do we know if 2, 5 is a solution to that inequality? Well, we would test it, right? So we would check it, see if it checks, see if it verifies, see if it satisfies that inequality, if it makes it true. If it makes it true and satisfies it, it is a solution. So I would rewrite that inequality with parentheses so that I can plug in those values of x and y, okay? So for this case, if x is 2 and y is 5, we're really trying to say, is it going to make that less than 15? So 4 minus 15 is less than 15. I know we're checking to see if that's true. What is 4 minus 15? And is negative 11 less than 15? Yes, so that is true. So this would be a solution, right? Okay. Okay, I'm not going to do two. Well, let's do maybe just one more. That's really easy. The 0, 0 is pretty quick to check, right? So again, if I'm checking, is 2 times 0 minus 3 times 0, is that going to be less than 15? Well, 0 minus 0 less than 15? Yes, 0 is less than 15, so that checks also. So it is a solution as well. Okay, so there's obviously going to be these infinite numbers of solutions that would be less than this. So how do we mark that? We were marking it with shading the line before. So I want you to think about, well, what would we do? Okay, well, I'll give you just a quick picture. We would shade a region. So we would cut our coordinate grid into 2 parts, just like we cut the number line into 2 parts. We would shade left or right, up or down. It's all relative to how we write our equation, okay? So first we would, if we look at our steps down here, write that inequality in. So y equals mx plus b form is just quicker for me to write, but it really means that we're going to put it in slope-intercept form, right? The reason we do that, it's just quicker to graph because I know the slope tells me how to move and the y-intercept tells me where to begin, right? So if we graph that inequality, we would, I want you to think about this for a minute. What do you think we would do if it was a less than or greater than, and we don't want to include the equation itself? Well, when we didn't want to include a number, we did an open circle. So how can we apply that to the line that we're going to draw? Instead of an open circle, we would have an open line. So the best way that we can do that is to make it a broken line, or an open line, dashed line is what we're going to say. So we would use a dashed line if it was a greater than or less than, and we didn't want to include any of the points on the line. Therefore, we would use a solid line if we did want to include this equal to part, include all the points that are on the line as well in our solution. Okay. Now, how do we know after we graph our line whether to shade this region or this region if it divides it into two regions? Well, we are going to use something called a test point. Just to determine, like we did up above. So we pick a point. Will it satisfy it? If it will satisfy it, whatever region it's in is the region that we would shade. Okay. All the points within that shaded region would be solutions to the inequality as well. Okay. Okay, well, let's flip this over. And so that we don't have to keep going back and forth, I've kind of just written a little synopsis of this. We graph the line, y equals mx plus b, solve it for y. If it's a dotted, it's a dotted line if we have less than or greater than, and it is a solid line if we have that inclusive part, the equal to part, okay? A little or in there, okay? After we've done that, we're gonna test the point that's not on the line and determine if it's a solution or not. If it's a solution, whatever region it's in, we're gonna shade, all right? So let's just practice it right here with y is less than or equal to 4x plus 3. Is it already in slope-intercept form? Yes, so that part's easy. Where am I going to begin? 3 on the y-axis, 1, 2, 3. How does this line move? The slope is 4 over 1. I'm going to rise 4, run to the right 1. 1, 2, 3, 4 over 1. Now negative 4 and negative 1 are equivalent, right? Negative 4 down. Sorry, 1, 2, 3, 4, negative 1 to the left. 1, 2, 3, 4, negative, equivalent. Negative 4 over negative 1, positive 4 over positive 1. So am I going to make this a solid line or a dashed line? Well, the equal to part means we want to include all the points that are on the line. So we're going to make it a solid line, right? So go ahead and draw that. Okay. Now, do I shade this region or this region? Let's pick a test point. The best test point is the origin because it's very easy to plug in to an equation and do that math in your head, okay? So would 0 be less than or equal to 4 times 0 plus 3? Well, this is just 0. See how we can do that in our head then? Is 0 less than or equal to 3? Yes, 0 is less than or equal to 3, right? So this is a solution to the inequality. Therefore, it should be in the shaded region, right? So we are going to shade this portion of the graph. And everything on this portion of the graph would be a solution to the inequality. We could pick any point, plug it in, it would satisfy it, okay? None of these would plug in and satisfy it, all right? Let's try another one. This one's already solved for y also, so that'll make it nice and easy. Where do I begin? Negative 6. 1, 2, 3, 4, 5, 6. Okay, and how am I going to move? I'm going to go down 1 over 2. So I'm not rising, I'm falling 1. and running to the right 2, fall, and run. And so I've run out of room. Again, I can go do this reversing. I'm going down 1 and right 2. I could go up 1 and left 2 though, to graph in reverse, left to right order. Okay, so the more points we get, the more accurate our line's going to be. Since it is a greater than symbol, it's not inclusive, so I'm going to do this broken or dashed line, right? So put this on here, and I usually just go in between the coordinates that I have graphed. We want to be able to see it stand out even after we do our shading, okay? Great test point would be 0, 0. So we put 0 here, 0 there. We're checking, is 0 greater than 1/2 times 0 minus 6? And this just winds up being 0, right? Is 0 greater than -6? Yes, it is. So this is a solution, which means I'm going to shade the region that has 0, 0 in it. This is our boundary, right? So remember, we said that linear inequality was this boundary line, and the region that we shade are all the solutions. All right, let's try a couple more, and then you're going to be doing some practice on your own. The difference here is that we have to solve for y. We have to put it in slope-intercept. Now, sometimes we can just do it by intercepts if it's in standard form like this one, ax plus by equals c, for example. But these don't have some friendly numbers in order to do that. So if we solve this, we would get 2y is greater than -3x plus 4. I want you to keep in the back of your mind that we still have those rules that if when you're solving, you are dividing by a negative or multiplying by a negative, you'd have to switch your inequality symbol, right? We're not going to run into this problem right now. Divide by 2, everything. -3 over 2x. 4 divided by 2 is just going to be 2. Okay. Where am I going to begin? +2 on the y-intercept. How am I going to move? Slope is -3 over 2. I'm going to fall 3, run to the right 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1. Oh, I'm sorry. 1, 2, 3, 1, 2. And I can, instead of falling, rise 3, 1, 2, and go -2 on the x, change. 1, 2, 3, 1, 2. Okay. So again, the more points I get, the more accurate my line is going to be. When I connect all of these points, am I going to use solid or dashed? It's not inclusive. We don't have any equality portion to our statement, so it's going to be a dashed line. So I'm going to go this one. I could probably afford to put a couple in between each dot. Okay. Remember to be drawing your graphs all the way through the coordinate and putting your arrows on the end, right? Now I have to do another test point, and 0, 0 is going to work pretty well on this one too. So we'll plug it in. If I put 0 here and 0 here, will it be greater than? So -3 over 2 times 0, again, is just going to be 0. And then I'm left with 2. Is 0 greater than 2? No, it's not. So this test point has just failed to satisfy it. So it is not a solution. I have to shade on the other side of this line, this region. Okay. 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 One last one here. Sorry. I'm going to add x to both sides. Okay. Oh, sorry, there's a 4 right there. And then I have to divide everything by 4. So that's going to be 3. This is going to be 1/4 x, and dividing by 4 is the same as multiplying by 1/4. Again, we're going to begin at the y-intercept at 3 here. And our rise overrun, up 1 over 4, up 1 right 4. 1, 2, 3, 4. So not a very steep line. Okay, 1, 2, 3, 4. Okay, and solid or dashed. It's got an equal to sign to it. So I want to include the points that are on the line. So I'm going to do a solid line and pick my test point again as 0, 0. And plug it in. And will this be greater than or equal to? That's just going to be 0, right? Is 0 less than, I said greater than, I apologize. Is 0 less than or equal to 3? It's less than 3. So yes, this is going to be part of my solution. Now, sometimes we might have a line that actually goes through the origin, and then we're not going to pick 0, 0 as our test point. You know, if it's too close to the origin, then you need to pick something else and try to make it easy. 1, 1, for example. Okay, so just something that would be easy to plug in and do in your head or do the math very quickly. Okay, now some people are able to figure out what side of this line to shade just based on the inequality symbol. Okay, I didn't want to talk about this till the very end, but if we look at this, we have a y is less than or equal to. So from our graph, we want on including this line, all of the y values that would be less than those on this line. And so if we think about this line right here, okay, that from where it intersects the y-axis, all of these coordinates are greater than, and all of these are less than, right? So for y being less than this line, it would be below it, right? For this one, we had greater than, right? For the line here where it crosses, these are the y values that are greater than, aren't they? And these are y values that are less than. Let's try it on these last two. Y being greater than, notice that we shaded above the line. And here we had y being less than, and we shaded below the line. Sometimes it's not obvious to tell above and below, depending on the steepness of the line though. So it's still advised that you do a test point, okay? Okay, I think that's it. You need to get into your practice now. If you need any help, make sure you're contacting your teacher, and good luck with this, okay?